In today's video, we'll be making a PCB for a clipper circuit and a clamper circuit. So I've already made a circuit diagram. I've already placed the components which are used in making the circuit of a clipper. So this is a negative clipper, but I'll be explaining each and every component to you one by one. So first of all, what we have to do is I also want to check out whether we are getting an output waveform corresponding to an input waveform. So what we'll do is we'll create the environment first for the circuit simulation. For that, we have to make sure that the easy EDA over at the top is changed into the simulation mode from the standard mode. So standard mode is preferred if we have to draw the schematic, and schematic can be drawn in both the modes, whereas PCB layout will be is supported in the standard mode and the circuit simulation is supported in the simulation mode. So this will be very helpful. So if we first change it into the simulation mode and then we again go to new and then open the project or the schematic whatsoever we have. So I have named my project as the clipper circuit, and in that I have created a negative clipper. So now I can get the library components on the left hand side, and I can even use the signal generator here, but now here I am taking only the AC source because we know that we should have the AC source at the input. So there are some default values which are set for the sinusoidal AC source. We can change them by simply double clicking on it, and we can change the values. So there are 6 parameters, I guess, and they are V0, VA, frequency, TD, and theta. V0 is the offset, which is obviously the first parameter. It should be 0. Then VA is the amplitude, that is which I have set as 10 volts. I have set the amplitude. Then 20 kilohertz, I'm setting the frequency, and then you have the delay, then we have the theta, damping factor, and other. So I've put all as 0. So I'm taking only 3 parameters into account. That is, first is the delay, or the first is the offset, then the amplitude and the frequency. So I've set it as 0, 10, and 20. So this is how it is. And then I've taken up a diode 1N4148, which is easily available in the library. If not this, you can even use 1N4001, whatever you like. And then I've used a resistor with a value of 1 kilo ohm. And I've used a DC voltage source. I've taken it from here only. That is, this VDC. It can be taken if if I select this, take up this and place it here. So this is how it is. I have placed this thing here. So now, since my circuit is complete over there, I'll delete it because I've already used it. So we just have to do one thing. In the library section, go to the sources, click on the voltage source, then drop down menu. You have various voltage sources: VDC, V sine, V pulse, V exponential, and so on and so forth. And then use a resistor. So obviously we can we have joined these components using the wiring tool, which you already know. We have placed a ground terminal over here, and we have the voltage probes here, which I have taken from the wiring tool. So here is a voltage probe. I have taken it from the wiring tools, and I have placed it at the input section, input corner, and I've placed it at the output terminal. These voltage probes will obviously measure the voltage at the input and the output. Now next, what and one more thing, the DC source which I'm using, I have used a magnitude of 1 volt DC. Okay, I can use 2, I can use 3, and so on. By changing the value, I can change. If I need to change the value, I can change it here only. So now it's complete. We can go to file, we can go to save, and we can go to simulation. So run your simulation. So the simulation is complete, and now what do we have? It is showing in blue V out, and in it's in orange it's V in, or in dark yellow. So to separate the two waveforms, we go to this button, we click on. So name belong pane, it's V out 1, V in 2. So to separate the two, we'll select 1 as 2 and then apply it. And now you can see that this is the portion of the waveform above 1 volts has been clipped off, whereas the negative side is there. So this is a positive clipping, and this is the input waveform. So corresponding to the input waveform, you can compare the output waveform and see what we have got. So if we change the magnitude of V1, if we change the magnitude of V1, we set it as 3 and save it. That means now it's 3 volts. Now it should clip above 3 volts. So again, run the simulation. Okay, separate the two to see, apply. So this is how it is, huh? So above 3 everything is clipped off and below 3 it is there. So this is a positive clipper. Now if we want to have negative clipping, simply change the orientation of the diode like this. Go to file, save it, simulation, run your simulation. Okay, now separate the two. Change the magnitude, whatever you want for the DC, whatever you want for the AC, and you will see that the portion of the waveform below the 3 volts has been clipped off, so it's a negative clipping. It's negative clipping. Okay. So this confirms that the circuit which we are making is correct. Okay. Now I'll close some of these waveforms because I've already saved the one which I needed. Yeah. And now I'll come to the clamper circuit. So the clamper circuit is here. The clamper is similar to that of a clipper. We can add a DC voltage source to it, but in addition to a clipper circuit, it has a capacitor here. So we can see a capacitive element, that is C2, which I have placed here. So capacitor I have selected from here. It's just not a metal plate capacitor. I have selected an electrolytic capacitor. So this electrolytic capacitor, I have saved it here and I have used its value. I can change the value over here, which is text. I can keep it as 10 microfarads, 100 microfarads, whatever is my requirement. So the sine wave is again the input is again a sine wave with an offset of 0, with a amplitude of 10, but with a frequency of 10 kilohertz only. So here I have the diode which is placed in this very position. I have a resistor, output resistor or the load resistor with a value of 10 kilo ohms, and I have again used the input and the output probes. So I have to see that the purpose of the clamper circuit is satisfied. That is, it must clamp the output waveform into either the positive direction or into the negative direction. Now, taking this circuit into account, if we, if we recall the working of this very circuit, it would obviously do a negative clamping. So let us see. So simulation, run your simulation. Yeah. Okay, I've changed the orientation of the diode and it is giving us a positive clamping. That is fine. Yeah. So now see. So it was first like the amplitude must remain the same. That is peak to peak amplitude, it's 10, 10, it's 20. So you can see from here the positive clamping has taken place and the peak to peak amplitude is 20. Now if we do one thing, we change the orientation of this diode, that is if we rotate it into this very direction, then go and save the file and then run the simulation, we'll get obviously a negative clamping. So again, let's go to start. Let's separate the two, apply and see. See, the voltage waveform has been shifted to the negative direction, but however the peak to peak voltage has remained the same. Okay, so now this is done with the this so that's done. And okay, I'll save to existing project and clamper. I'll write the waveforms. Okay, so it's saved. Okay, we can even export the data as CSV, which is here if you want to plot it somewhere else, although that is not required in your way. So this is done. We will close this. So the clipper circuit is done, everything is done, so we will close this. Now we will go to one thing, we will change it to the standard mode. So we have changed it into the standard mode. For the standard mode, we have to use a connector. If it is not showing in here, what we do is we take, just a moment. Okay, delete. Okay, I've only changed the mode. So for the PCB, I need to change it to the PCB. Okay, so let me keep the sign, input voltage source like this only. Let me keep the ground like this. Let me save the file. Okay, it has been saved, and then let me just directly go to convert to PCB. Let me see what happens. Okay, so it's showing an error. So what is the error? Error is that the symbol pin number of the component does not match the associated footprint pad number. Please modify the symbol pin number or reassociate the footprint. Okay, so what we need to do is that this diode, which I have used here, its footprint is not present in the library of the standard simulation mode. So let me just delete it and go to the library whose footprint is present. Let me go to the diode, whatever जिसका भी footprint available होगा. Let's go to that diode. Let us search like this one N4001. Okay, okay. So this is here. Okay, place R. So that's done. Now let's see. Save, convert to PCB. So the PCB is here. All of the components have been identified, the footprints are there, we need to check it, and we have already checked the working of the circuit. Now we have made the PCB. Very simple. So first we'll go to the border outline, we will go to board outline, we'll take up the tool, that is the track, and we will draw the track like this. So this is our board now. Okay, now let's just go to the placement of the components. So this is a capacitor, this is our voltage source, this is our D1, and so on and so forth. Okay, 1 end of the capacitor, second end of the capacitor, third end like this. Okay, and like this. Okay, remember we have to save the space as well. So that's done. Cool. A very simple PCB. So let's go to the bottom layer, take up the tool and start Okay. Mm-hmm. Clamper positive of the capacitor is connected to the voltage source. Okay, right. Take it here again. Take it here. Take it here. Hmm. Okay. Yeah, all done. Okay, so that's all done. It only requires the bottom layer. Now we just want to see a 3D view. So this is our 3D view. One resistor, one diode, one capacitor, and one voltage source. The connections are like this. Okay, so this is how we have made the PCB. We can, however, minimize the space because PCB is very small. So let's minimize the space like this. Okay, again, file, save. It has been saved. It's a photo view. Then, okay, go to the 3D, a smaller PCB, right? So that's how it is done. So this completes the PCB of the clamper circuit. Okay, and similarly we'll do with the clipper circuit. Okay, so this is our clipper. We just I guess we'll take out these voltage probes. We'll remove these voltage probes. We'll remove the voltage probes here. Rest all is okay. Let us first check what happens. So we need to save it. Okay, it's showing it that it is saved, and let us convert it to PCB. Okay, so all good, all identified, footprints available, diode, resistor, voltage source, and V2. Okay, but we must remember that V2 is a AC source and V1 is the DC source. Although it will not make a difference, but only when we attach the components onto the PCB, we must know which slot is for the DC source and which slot is for the AC source. That is it. So it's here. Again, we'll go to the board outline. We'll take up the tool. We'll draw the circuit. We'll draw the board outline. Okay, so that is it is completed. Now we have V1. Okay, the only thing why we are doing this is that this components must not get shorted. Okay, here we can rotate it. Yeah, see, it will not get shorted. Rotate. Yeah, that is it. It's done. So let's check out bottom layer. Go to the wiring. It will itself drag us to the wiring. Okay, then go to here, go to here, go to here where it becomes white. That means we have to make the connections there. Yes, so that's it. It is complete. We will make it like this and we will save it. We'll check design rules, DRC, so there are no errors. 2D. So this is showing you 2D, but it is not showing you the components. So we'll go to the 3D view. I don't understand. Why is it showing it? No, no, no. So something is wrong with this. Not an issue. We'll do it again. Okay. This one now. So transform it into the PCB. Rectangular. Apply. Board outline. This thing. Okay. V1 over here. V2 over here, but rotated. Okay. Then resistor. Rotated. Okay, or else yeah, that is fine. So this is how it is. So we'll go to the bottom layer, we'll go to tools, we'll use the connections like this. Okay, so that's all done. So this is all done. We'll go to file, we'll go to save, DRC, no errors, and 3D. So here is the PCB for V1, V2 voltage source connections, R1 resistor, and the diode D1. Here it is how it looks like. So this is how we have made a PCB. So you can see even the diode has been inserted. I hope this is clear to all of you.